Shri Kumarswami College Ausa is feeling immense pleasure to have all the honorable dignitaries, delegates, and participants here at the virtual platform for the International E-Conference in Mathematics. Shri Kumarswami College Ausa is run by Shri Mahant Swami Shikshan Prasarak Mandal Ausa. The college conducts various innovative activities for the benefit of students, researchers, and all the stakeholders. Today, the International E-Conference has been organized by Department of Mathematics, Shri Kumarswami College Ausa. For this international conference, first of all, I would like to welcome Chief Organizer, Honorable Principal Dr. M. Ambedkar sir, who takes continuous efforts to arrange national and international webinars and conferences. Sir, I heartily welcome you as the chairperson of this International E-Conference in Mathematics. The topic of International E-Conference is the attitudes towards mathematics and learning styles. Today we are feeling very honored to have the international chief guest and keynote speaker, Honorable Herdiana Dewi Nurfika ma'am, who is founder and CEO of Bliss Education Center, Indonesia. On behalf of the organizing committee and Shri Kumarswami College Ausa, I heartily welcome you, ma'am, as the keynote speaker. We are having lot of pleasure to have the technical session chair, respected Dr. Handibag sir, SS, who is research supervisor and HOD mathematics at Sri Mahatma Bashweshwar Mahavidyalaya, Latur. I welcome you, sir, on behalf of the college and the organizing committee. I also welcome the convener of this International E-Conference, Jyoti Bhosle ma'am, HOD Mathematics, Shri Kumarswami College, Ausa. Now after this, I would like to invite the chairperson and chief organizer of this International E-Conference for his introductory speech. Please, sir, welcome.
Thank you, Prashant sir, Professor Prashant sir. Today's international event, that is the international conference organized by Department of Mathematics of our college, Sri Kumarswami Mahavidyalaya, Ausa district, Latur. The topic is the attitude toward the mathematics and learning styles. While searching on the social media, the resource person I am well knowing from so many days to Herdiana Devi madam on other dais also. So I welcome her. I was knowing her potential and requested to join here as a resource person to this international event of mathematics conference. So welcome madam from my college, my all organizing team to you. Also head of department Mrs. Jyoti Bhosle madam, and who just introduced our conference event coordinator Prakash Karad sir, and the SS Handibag sir, who is session chair of this international event from head department of mathematics from our Bashweshwar Mahavidyalaya, Latur. I welcome all the participants, all the teachers, all the faculties joined from India and abroad for this mathematics international conference. I welcome all of you and now hand over this event towards Prakash Karad sir. Thank you and welcome to madam.
them they were not even good, or maybe they are bad, or their attitude is not good, blah blah blah. Please don't make a label on that kind of attitude towards the student, because consciously it's going to affect how you interact with those students too, which is going to sending the signal to the students that you don't like them, which is going to make them such as resistant to learn something from you. But when you are open hand, when you are being kind, being truly communicative with them, then they can foster a comfortable space for learning with you or around you. So it's really important for teachers and a learner to be a great team in order to get a good achievement. So, in the founding, in the research that I have mentioned before, there's implication and insight that motivation and engagement, which is foster a positive attitude, it's going to truly influence the students to invest more time and effort in understanding mathematical concept, for example. Because when you don't even encourage your students and rather you just yell at them, for example, or you blame them because they got a bad score, let's say, then they might want to learn it, but they will be scared. And when we are scared, when we are under pressure, we might be the best, because we know that some people make the best version of themselves by getting hurt by other people. They might achieve a better score, maybe, but one thing as educators, you need to think in the long term. Once they feel it, once they got such a booster in a negative ways, one day in their adulthood, it's going to be a trauma for them. Okay, that's why it's truly important to remind a positive attitude since the beginning. Maybe some students feel like, okay, I want to get the better score because my teacher said I can't, so I have to prove it. It's a good affirmation for the student itself. But if you are trying to trigger your students in a way that you act like you don't believe that they can do it, then it's going to make them get kind of lack of confidence and also comfort. So they will not be comfortable much while doing the process. Next is resilience and persistence. If we foster a positive attitude, of course, it's going to bring more resilience when faced with challenges, because the students are going to get a reminder by the lecturer or by the educators that the challenges are actually the opportunities for you to explore more, to try more ways to get the exact point, for example. And then when we foster positive attitude, of course, it's going to persisting through difficulties and overcoming obstacles in the learning process. Because many students feel like they are having anxiety when even heard about mathematics. So we truly need to foster a positive attitude toward this matter. Next is teacher-student dynamics. Okay, so the role of teachers in shaping positive attitude is truly important. You need to be supportive. You need to encourage the students. You need to practice and contribute significantly to fostering a favorable attitude towards mathematics. Not only hoping your students get the best score, but showing them how you actually trust them, how you actually not putting label no matter how bad their grade in the last exam, for example. It's actually not easy too for educators for not putting a label on the students when we have seen them for more than a year, for more than 1 month, 3 months, for example. Because as a human, we naturally sometimes have some kind of thoughts about the specific person after we spend enough time with them. So even though you felt like I have known the students for a long time and he or she just didn't make it well for the exam, even if you have experience, please believe that as long as you keep fostering a positive attitude, then there might be a change as well. Because we need to remind them, you need to guide them. Okay, you cannot expect them to get into the destination without your guidance. And during the guidance process, it means that you also need your open, warmly hands to them, not being such a killer teacher, such a dictator teacher, for example. Because even when we just think about mathematics, it's already difficult for some people. So being or appear as a difficult teacher is actually adding an extra stress for our students. Okay. So these are kind of teaching strategy for positive attitude. Okay, can I continue?
Yes, ma'am.
Okay. Okay.
Yes,
So
madam. Continue.
the first is we need to bring a real world problem solving. Okay, so we can integrate a real world scenarios to demonstrate the relevance of mathematical concept. In the next slide, I'm going to provide an example. And then we also need to always engagement by connecting mathematical problems to students' daily life so they can get better and also faster understanding about the problem. Next is, of course, collaborative learning, which means that we need to emphasize the value of diverse problem solving approach within a collaborative setting so they are not going to get bored easily. Next is our differentiate instruction. We need to recognize that diverse learning styles through varied teaching methods. That's really important because we are having students in the classroom with the variety of learning style. Okay, so we need to tailor lesson to address individual strengths and challenges to promote inclusivity too in the classroom. And then not only that, we also need to encourage questioning and curiosity. We open the students to ask more about the methods, for example, not being a strict one and not allowing them to speak up because we need to cultivate a classroom where we value the curiosity. We need to understand, especially as educator, that when student asks why, it means that they are actually showing the enthusiasm. So please don't shut them up when they are showing their enthusiasm. Okay. So the example here, when we talk about the real world problem solving, for example, in a geometry lesson, when a student wants to learn this concept, you can explore the concept of angels by designing a blueprint for a park. You can consider a real world constraint and also optimizing the layout for recreational activities. So they understand, okay, when I go to park, actually, it's included the concept of geometry that I have learned at school, for example. Next, with the collaborative learning, for example, you can ask your students to work in a small group to solve a challenging algebra problem. So we can ask them to discuss different approaches and collectively presenting their solution to the class. So it's not only about solve number 1 to 10 in the classroom, write down on the whiteboard, but when we ask them to discuss different approaches, we also foster a critical thinking for them, which is our generation need in this era. Okay. Next, for the differentiate instruction, we can ask them to provide different activities to cater a various learning style. For example, for visual learner, they can use manipulative. Auditory learners can engage more in the group discussion, and for kinesthetic learners, they can participate in hands-on activities. So when we want to encourage curiosity in the classroom, we can ask the student to start questioning or asking the probing question about the application of different derivatives or maybe about related another concept too. So in the classroom, we can collectively explore this question even in the different concept, which means that we are going to foster a culture of curiosity and inquiry. So they are feeling like, okay, my teachers are going to listen me, and then I also need to challenge myself to get to know more. When one student asks one question, usually the other students start asking, but sometimes as teacher we are waiting the first one longer than the second and the third one. So in this session, I'd like to adapting different learning style in the classroom. For example, visual learner, you can use the visual aids such as graphs, chart, and diagram. I do believe that the lecturers in this university are already doing that, and you can also try to put a concept of slope in linear equation, or maybe you can try to visually represent on a graph, highlighting the rise and the run to help visual learners grasp the geometric interpretation. Or if you are thinking that you have more auditory learners in the classroom, you can try to encourage them to discuss more. For example, while teaching algebra, you can ask them to discuss and explain the problem solving steps verbally without written on the text on the textbook or in their notebook, for example. And then you can use the mnemonics or chants for remembering the key formulas. Maybe it's going to be fun for them to chant the formulas in front of the classroom together with the other students. And for the kinesthetic learner, maybe you can allow them to physically construct shapes using materials like clay or building blocks. It might sound like too childish, for example, for university students, but actually this kind of experience can enhance their understanding of special relationship toward the concept. But you maybe can try it only once to building the blocks rather than just clay, for example, because it's going to be sound like more advanced when you are trying to build blocks to relate it the issues that you are currently teaching. Next, for the reading or writing learners, of course, you can always try to over written explanation and encourage the students to write out their problem solving steps rather than only saying and writing down what you have written on the whiteboard, for example. So you can utilize the mathematical journals for students to express their understanding through writing. Maybe you can ask them to write one summarization in one paragraph, not about making 1 point until 10 points, for example, like you have explained in the classroom. Because when you are asking them to summarize something, to make it in their own voice, then we actually can see or can notice how much or how deep their understanding about the concept. Next is multimodal learning. We can mix actually whether they are auditory, we can make a discussion, or we can make a hands-on activity for the kinesthetic, or we can ask them to write reflection on reading or the writing. And next, for the differentiated instruction, we can use more visual aids like fraction bars for visual learners or engage auditory learners in discussion. Okay, and then next, because we live in a digital age, it's also important to use the technology integration. We know that OpenAI has built many new platforms. Many students have used even ChatGPT 4, which is pro feature to even solve the mathematical problems. I'm not going to against the new trends, but as educator, as a teacher, especially in math, you also need to pin or to highlight where the students can use the technology and where they need to stop to discover it in order to not make them lazy to think or to be as person or a student with the high critical thinking. Okay, so I do believe that maybe you have integrated some technology in your classroom, because if I have to mention one by one, maybe you might know more as this is your field. But from my side, I think it's truly important to setting boundaries in the classroom when we talk about the technology. But it's always nice to introduce the technology to the students, especially nowadays, because yeah, if we open the YouTube, for example, you gave a homework for your students and they don't know how to solve then they might come to YouTube first. They ask the keywords, how to blah blah blah, and they might watch it, and then they might get a clearer understanding about it. So it's still normal in that way, but you also need to keep reminding them in what ways they can do for answering the homework, so it's going to be clear. So okay, we almost come to the end of this presentation. I'd like to remind the learning techniques for the students, because math is going to be long process. So please, when you want to study, set a clear time. You can try Pomodoro techniques, which is you can download the application, whether you are using iPhone or Android. There is some kind of Pomodoro technique application that you can set on your phone. So you can decide which task that you want to do first, and also you can set the timer, which is going to be great, because in Pomodoro technique, we put a break during the session, which means that you are letting your brain to a break, so you can think clearer, okay, before you start new journey or new times to learn more, okay. So maybe after this, you can try to discover the application on your phone about the Pomodoro technique that can become such a reminder. Okay, so sorry. Okay, before we end of the session, because math is such a difficult concept or difficult subject for some students, I want to remind the students and also the teachers to keep your daily dose of happiness, which means that keep your dopamine, oxytocin, serotonin, and also endorphins. Okay, it's as you can see, this kind of things, it's actually going to deficiency affects you, and also you can increase the happiness levels in many ways. That, but I want to give you one way tips that you can do, and you can get the hack for all of this dose of happiness. First, if you feel like you burn out of the learning process or for the teaching moment as a teacher, you can make a plan for jogging outside under the sunlight with your family members or with your friends, because when you set a goal or when you set a plan, you are going to increase your dopamine, and when you are doing it with your friends, with your family, or with your loved one, which means that it's going to increase your oxytocin, because it's a love hormone. And when you do this under the sunlight, for example, you do exercise or even jogging with your friends, it's going to increase your serotonin at the same time. And we believe that during the process, when you hang out with your friends, your family members, you might have a moment when you laugh together, when you maybe feel connect with them. It's going to release your pain relievers or endorphins. So with that being said, when you make a plan for having exercise together, for jogging, for maintaining a balance, a healthy lifestyle with your friends together under the sunlight, for example, then you can increase all this dose of happiness. So once you feel like you burn out for doing your homework, you burn out for teaching math because of your students didn't get a good score, for example, please recharge your energy. Please keep your daily dose of happiness. Okay. Next is the conclusion. Okay, we come to the end of the session, and I have explained about the learning style, and I want to highlight that by understanding and bridging the gap between the attitude and learning approach, actually educators or teachers and students can foster more positive and also effective mathematics learning environment, which is going to lead you with a better or even higher grade of student achievement at the end of the semester. Okay, we always need to encourage them to try more and to not putting label on them, so we can foster really a positive environment to them. So thank you so much for your time and for your attention and for joining in the session. I hope that you can have some takeaway from my presentation. And if you have any question, you can write it down in the chat box, or maybe you can unmute yourself. Thank you so much.
Thank you very much, ma'am, for
Thank
your
you.
informative and enlightening lecture on the topic, the attitudes toward mathematics and learning styles. It was very encouraging for students and educators of mathematics. It was very valuable. So, on behalf of the organizing committee and the college, I extend sincere thanks for sharing your precious time and imparting your valuable knowledge about the topic. So I am very grateful on behalf of the college. Thank you very much.
Thank you so
Now
much.
after this, now after this keynote speech delivered by the speaker, okay, sir. Now I would like to request delegates, if you have any question, if you have any point to place, or if you have any query, please come with it. Delegates and participants.
Hello, good evening, Dr. Bedkar, sir. Good evening, all organizing committee members, and good evening, wonderful presentation, ma'am. Thank you very much for your wonderful presentation on mathematics. Especially for me personally, mathematics was little difficult, and that is why I turned to medical field. Yes, but there are various facets of mathematics, various kinds of different mathematics are there, algebra and other things, and then what we are learning in colleges, probability and integration and other aspects. So it becomes little difficult and difficult. My question is, how to make mathematics easier, because mathematics is a part of statistics, mathematics is a part of physics, it is a part of chemistry everywhere, even in biology also we are calculating chromosomes and we are having. So mathematics is what I feel, it is a kind of a foundation to make it strong, right? What we should do, my teacher used to say, you practice various kinds of problems, solve them, and you'll become master. And some people said that you keep solving the problems so you can achieve the higher means little difficult complex problems also. So whether it is right or wrong, and if suppose some of my patients or someone is asking for mathematics, what is easy key to learn mathematics? Thank you.
Thank you so much, Dr. Swaran Shukla, for your question. It's actually a great question. As I have said in the beginning, actually we lived around mathematics since we were child, even when we were not in the elementary school or even in the kindergarten. Even after we graduate from the college, for example, we will still see math in our lives. So the thing is, when we want to learn mathematics, please keep on your mind that whatever the concept, the new concept that you are going to learn or you are willing to learn, it's going to add value. Sometimes the thing is, when we learn, for example, you mentioned that mathematics is also important in statistics too. It's correct. When you want to learn new concept, please understand where you are going to implement it in a real life. That's why I put in my slide, as teachers, we need to integrate with real life scenarios, with real activities or daily, so the students can really get a better understanding where actually we are going to implement this. Because some of the students might think like, why do I need to learn algebra when I work as accountant? I'm not going to use it. I'm not going to use this kind of the concept. So it's really important, and also the responsibility for teachers. If you think that the material is so difficult, you need to highlight to them where they are going to learn it, why they have to master this concept so they can get better understanding while they are working on specific subject, for example. And then it's actually true. When we want to master mathematics, we need to keep practicing. Like I have shown in the video, we got million neurons on our mind. Okay, so the neurons on our brain is going to create the new connection once we do something new. Even when we see something new, like right now you are listening, you are watching my presentation, it's going to create new neuron on your brain. And once you keep practicing, or once you keep watching the same topic, it's going to make your neuron connection stronger. That's why it's correct when the teacher suggests you to keep practicing, which means that the more you practice, the stronger connection that you can build on your brain for the neuron. So once you get a stronger connection on your brain, then you maybe, let's say, got a new question, but it's maybe not completely same but similar, then your brain know how to solve this problem because it's similar or it's familiar for them. But when you didn't practice at all, it seems like very rare to your brain. How can you expect your brain to instantly answer the question when you are not even ever making a connection on your brain for that specific? So practicing is always good, but like I have mentioned, when you want to learn something, whether it's mathematics, whether it's another subject, please remind yourself that you need to foster a positive attitude, because we know that mathematics is not easy, but it's really important. Okay, so when you try and it didn't work at the first time, don't worry that you are having another change, or you are having another time to keep practicing, to keep learning it. Because the thing is, if another person can, let's say, get 90 or 100, then it means that there is a change for you to be able to get that. So practice is always good time for you, but bringing the positive attitude within yourself is the first gate. Because once you put a label, oh my God, I don't like mathematics, I'm not good at mathematics, then how could you be good? You don't even believe in yourself, and how could your teacher believe that you are going to get 100? So if you want to get 100, then you need to believe that you have that ability. But believing in yourself only is not going to bring you anywhere. You also need to put efforts. You need to stick with the plan, the study plans where you are going to learn. Okay, I hope it can answer the question. If you have any other question, please don't hesitate to ask. Thank you so much.
Yeah, thank you.
Thank you.
Thank you very much, ma'am, for your wonderful explanation. And really, the teacher played a vital role in this, to make it a little easier. It should not be a boredom for the students. So wonderful. And teacher like you, definitely, they must be doing this kind of job. Thank you. Thank you very much, ma'am.
Thank you so much.
Thank you, Dr. Swanand Shukla, sir, for your question. And thank you, ma'am, for an elaborate and illustrative answer. And the gist of answer is math is difficult, but it is an integral part of our life. So we should positively try to learn it and tackle it. Thank you very much. Now, after this, I would like to request, is there any participant or delegate who wants to ask any question, please? Thank you, sir. Very, very useful uh, keynote speech and also question answer session. There was only one question, but it was very comprehensive and the answer was very elaborate. And after this fruitful session, on behalf of the committee, once again, I sincerely extend my thanks to Honorable keynote speaker for her very enriching and enlightening lecture on the topic. Now, after this, it is time for all of us to go for the technical session. And for this technical session, we are having honor to have the respected chairperson of this technical session, Dr. Handibag Sujit sir, who is research supervisor and HOD Department of Mathematics at Sri Mahatma Bashweshwar College, Latur. Sir, I would like to invite you as the session chair and I will give you charge of this virtual platform to run the technical session. Please, Dr. Handibag, sir. Please.
Thank you, sir. Thank you, Karar, sir.
Welcome.
As a chairperson, good evening, all of you. As a chairperson of this session, I, on the behalf of chief organizer and organizing committee, I just inform to all the paper presenter who are going to present the paper in this e-conference on mathematics. They should conclude finish their presentation within the 5 minutes. After their presentation, there is a question answer session, question answer time, and there will be the 1 or 2 minutes for their. So for a paper presentation, I will call to first Miss Harsha KK to present their paper. Her paper title is Mathematics and Python. So Harsha KK, is there Harsha KK? Is there Miss Harsha KK? Okay, I think she's not here. So I request to the next paper presenter participant, Miss Deepika Solanki. Miss Deepika Solanki is the research scholar, and her paper title is a study on fuzzy set and fuzzy logic. So Miss Deepika Solanki, is there Miss Deepika? Madam Deepika ma'am? Okay, so I.
Thank you so much, Dr. Bedkar, and also for the organizer. I hope you all can continue the session in a really great way. Thank you so much once again. Bye bye.
Okay, so I just call to the next participant, paper presenter, Miss Tanya Dogra. Is there Tanya Dogra to present the paper?
Yes, sir.
Okay, so I request to the Miss Tanya Dogra to present their paper. Please, Miss Tanya Dogra, please share your screen and you can start your presentation. Tanya ma'am, you are not audible. So please unmute
Yes.
yourself. Yes. Screen is visible. You can start your session. Sorry,
Okay,
presentation.
sir. Okay, sir. First of all, good evening, one and all. I would like to thank the organizing committee for giving me this wonderful opportunity. And second, I would like to thank my audience for being present there. So this is my presentation. Is it visible to all? Okay.
Yes, ma'am. Yes, ma'am.
Okay, sir. So one second. Sir, is it visible now?
Yes, ma'am. Yes, ma'am. Go ahead.
Okay, sir. So, sir, this is my content slide in which we will be discussing about the introduction. My name is Tanya Dogra, and I am a MEd student. My research topic is mathematical anxiety among high school students in relation to their achievement in mathematics. So this is my content slide in which I'll be discussing about introduction, variables, objectives, hypothesis, operational definition, delimitations method, population sample, and so on. So I'll start with the introduction, like what mathematical anxiety is. Actually, mathematical anxiety refers to the feeling of tension, apprehension, and fear that can arise when individuals are faced with situation involving mathematics. Right? It is a psychological phenomena that can affect people of all ages and background. Most of the people most of the people get stuck when they are dealing with some maths. Now, in my study, the variables are achievement in mathematics and mathematical anxiety. So, the objective of my study is to study the level of mathematical anxiety among high school students. As my study is on high school, so the first objective is to study the level of mathematical anxiety among high school students. The second is to study the level of achievement in mathematics of high school students. Then to study the relationship between mathematical anxiety and achievement in mathematics among high school students in relation to gender with respect to two factors. As in my paper, we have two factors on which I have studied maths test anxiety and numerical anxiety, as well as the overall scores on mathematical anxiety. So, the next objective is to study the relationship between mathematical anxiety and achievement among high school students in relation to the residential background. Next is to study the relation between mathematical anxiety and achievement in mathematics among high school students in relation to the type of family with respect to the two factors MTA, which is maths test anxiety, and NA is numerical anxiety. And the last is to study the relationship between maths anxiety and achievement among high school students in relation to their economic status with respect to two factors and as well as the overall scores. Uh, so in residential background we have in residential background we have like two subparts of urban and rural areas and sorry. So next is hypothesis. First hypothesis is there is no significant relation between maths anxiety and achievement in mathematics among high school students in relation to their gender. We are considering male and female, and there is no significant relation between maths anxiety and achievement in maths among high school students in relation to their residential background of urban and rural areas. Next is there is no significant relationship between maths anxiety and achievement among high school students in relation to the type of family, joint or and nuclear. And last is there is no significant relationship between mathematical anxiety and achievement in mathematics among high school students in relation to their economic status. In this, we are taking null hypothesis. So these are my operational definitions. The first is mathematical anxiety. In this study, mathematical anxiety refers to scores obtained on mathematical anxiety scale developed by Karimi and Venkatesha 2011. And high school students are, in my study, refers to those students studying in 9th class in high school students. And achievement in mathematics refers to marks obtained by student in subject maths in 8th annual examination. So there are the delimitations of my study. The study has been delimited to 250 students studying in 9th class from 11 high to high secondary schools located in Jammu city. As I took the school in my nearby vicinity, so that is easy for me to take the scores of the student and fill the questionnaire. The study has been delimited to standardized tool, namely Mathematical Anxiety Scale India, developed by Karimi and Venkatesha 2011. And the method is descriptive survey method has been applied for the present study. And the population of my study are all the high school students from Jammu city. So there are 48,697 students enrolled in 9th class in Jammu city, in which 21,800 are girls and 26,897 are boys. These data has been collected from the UDICE app, UDICE website. And the sample of my study is 250 students studying in 9th class from 11th school located in Jammu city has been selected through simple random sampling technique. Am I audible?
Yes, ma'am. Yes, ma'am.
Yeah. Able.
Okay. These are my tools, and my tool is standardized, namely mathematical anxiety scale, as I have mentioned, developed by Karimi and Venkatesha, and my scale contains two factors, which is maths test anxiety and numerical anxiety, comprised of 36 items, in which maths test anxiety has 17 items and numerical anxiety has 19 items. So these are statistical techniques that has been employed in my study. First is present percentage, and second is Pearson coefficient correlation. So the results of my study is this is what I got from that scores, and this table shows that maximum number of students have average level of maths anxiety, as this table shows that 175 students out of 250 students have average level of maths anxiety. So as per the second objective, what I got is, and this table shows that 142 students out of 250 students have different level of achievements in mathematics, and and my range of my Z score is -2 to +2. The level of anxiety ranges from poor to high. This is my third table, which shows that there is no significant relationship between maths anxiety and achievement in mathematics with respect to the gender. Yes. Okay, sir. These are my findings, which shows that the majority of students have an average level of mathematical anxiety, and majority of students has an average level of achievement, as I already told you in my tables. There is no significant relation between maths anxiety between male and female, and no significant relation between maths anxiety and achievement in maths among high students residing in urban and rural areas. Also, there is no significant relation between maths anxiety and achievement in mathematics among high school students living in joint and nuclear families. But there is significant relation between maths anxiety and achievement in mathematics among high school students for the high economic factor, as it is shown in my results, which says that there is a negative relation between the achievement and anxiety between the students of high economic status. So it is concluded that there is no significant relation between maths anxiety and achievement in mathematics among high school students in relation to the gender, type of family, residential background, and low economic status. But there is a significant relation between maths anxiety and the academic achievement with high economic status for the factor of maths test anxiety. So there are some educational implications, and these are some suggestions and the references. Thank you. And last but not the least, I'd say that it is important for educators, parents, and individuals themselves to recognize maths anxiety and take necessary steps to address that. Thank you.
Okay. Thank you, ma'am. Thank you so much. So any question from the participant? Okay. Thank you, ma'am. There is no question. Thank you for your presentation. So I called for the next paper presenter, Dr. P.R. Kulkarni, sir. So is there Dr. P.R. Kulkarni, sir? Okay, he's not there. So I just called to the next presenter, Dr. Bhushan, HOD of Department of Physics, Digambarao Mahavidyalaya, Bokar. Dr.
Okay,
Bhushan,
thank you, sir. Thank you. I'm hearing.
Yes, okay, sir. So I request to the Dr. Bhushan, sir, to present their paper. So,
Okay,
Dr.
sir.
Bhushan, sir, you can share your screen. and try to finish your presentation within the time, sir.
Okay. My screen is sharing.
Okay, it's a working, sir.
Okay. I'm audible.
Yes, sir. Yes, sir.
The screen is on our computer.
Yes, sir. Screen is visible, but there is no any PPT. There is no any slide on screen.
Screen. Okay, sir. I am Dr. Bhupesh Nemaniwar, Assistant Professor and HOD, Department of Physics, Digambara Bindu Arts Science and College, Bhokar, District Nanded from Maharashtra. Here I am presenting my research paper. I am working in dielectric parameters at different temperatures. Today is entitled, my paper is Exploring Temperature Response, Thermodynamic and Physicochemical Attributes of 2-chloroaniline and in 2-alkoxyethanols environments. Means here 2-alkoxyethanols means here I am taking here 4 to 5 parameters: methanol, ethanol, propanol, butanol, hexanol, etc. That is in solute purpose, and 2-chloroaniline as a solute and alkoxyethanols are solvents. These two combinations were to take in different proportions and made the binary mixtures in nine compositions, and we have to measure the physical parameters as like that: density, viscosity, refractive index. Density we have to measure using Anton-Par densimeter made from Austria, which is reliability, accuracy, and reproducibility, that is 0.00001, up to this much accuracy and reliability for density, not what to use in traditional picnometer. And viscosity for measuring minus 100 degrees Celsius to plus 100 degrees Celsius. We have to take the Brookfield viscometer from USA, purchased from USA, and our refractive index measure traditional Abbe refractometer. Up to accuracy of that refractive index is up to third decimal of digits. We have to take the different binary mixtures and different temperatures from 293 Kelvin to 223 Kelvin. Using these parameters, we have to study the inter and intramolecular activity. What is the effect of in aniline group? We have to take the NH2, and in alkoxy group we have to use the OH. What is a combination of OH and NH2 at different solvents? Here we have to change the solvent, we have to keep the solute is constant. Our solute is 2-chloroaniline and our solvent is 2-alkoxyethanols. In 2-alkoxyethanols, we have to vary the OH group. Means methanol, next ethanol, next propanol, next butanol, next up to so on. And what is the effect of OH on NH2 at different temperature? After studying, I see that when temperature increases, the binary parameters values as like the density, viscosity, and refractive index is decreases if temperature increases. But here I will confidently say that when mole fraction of 2-chloroaniline is increases with any one of the 2-alkoxyethanol, our this physicochemical property values also increases. Means density, viscosity, refractive index, or excess parameters like excess density, excess viscosity, excess refractive index also increases when solute values are increases with solvent. But inverse proportion, these values are decreases when we have to increase the temperature. Here we have to say strongly says that there's a strong intermolecular interactions between aniline group of NH2 and alcohol group of OH. This is very useful. All data I cannot be here explained because lack of time. I cannot include the graph and tables. Only what to use. I can only say where we have to use this. This aniline group and alkox group were to use to petroleum solvents, fungicides, intermediate of production of agriculture chemicals, azodyes and pigment and pharmaceutical purpose. And two methoxyethanols, which is used in intermediate compound as biological drug synthesis, and two propoxyethanols, which is used in cellulose ester like inks, gums, varnishes, dyes, and all purpose of cleaning applications. Variety of cleaning applications were to use. And two ethoxyethanols, commercially it is called as cellosols. Widely it is used in complexes of solvents, stabilizers, emulsions, varnish removers, degreasing solutions, used in printing industry. When we have to take this is widely used in printing industry and additive for jet fuel to prevent ice build up. And lastly, here we have to conclude, based on this work, following conclusions can be made from us. Already we have to discuss that temperature increases, all these parameters values are decreases due to there is a distance between solute and soluble molecules up to that. But solute values of NH2 increases, means mole fraction of 2-chloroaniline increases, the value also increases. Here we have to strongly says that there is strongly bonded between solute and solute means aniline molecules and hydroxyl molecules. Here we have to increase the hydroxyl molecules, methane, ethane, propane, hexane, butane, etc. and so on. Thank you, sir. Thank you so much.
Thank you, Dr. Bhushan sir, for your kind presentation. So I just asked to the participant, is there any questions? So they can ask to the Mr. Bhushan sir. Is there any question from the participant? Okay, so there is no question. Thank you, Bhushan sir, for your presentation.
Thank you, sir. Thank you very much.
Okay. Thank you, Bedkar sir. There is no any other participant. I would like to say thanks to the chief organizer Bedkar sir, event coordinator.
Yes.
Okay. Sorry, sir. Sir. Okay. So now next participant is a PR Kulkarni sir. So I request to the PR Kulkarni sir. He is a HOD of the Department of Mathematics Science College in Nanded. So I request to the PR Kulkarni sir to present their paper, sir. Sir, you can share your screen, sir.
Thank you, sir. Thank you, Handibag, sir. Thank you very much. And good evening, all. Myself, Dr. Priyar Kulkarni from Science College, Department of Mathematics. I would like to present my paper here. So I'm sharing my screen. Yes, screen is being shared. Yes. I hope it is visible to all of you.
Yes, sir. It's a visible, sir. You can start now.
Okay, thank you. My title of the paper is An Investigation of Features of the Rossler System. So in this paper, I have considered a simple pendulum, which is under two kinds of forces, that is sinusoidal or harmonic driven force as a mechanical system. And we have studied here the oscillations of this simple pendulum, which is under the action of two forces. Just a minute. Okay. Right. So we have considered a driven pendulum whose mass is m and length is l. And suppose theta of t is the angle made by the pendulum with normal at time t, and d is the damping parameter, a d is the amplitude, omega d is the angular frequency of the periodic driven force. The driven force is ad omega, sine omega t. So this is a harmonic driven force. So in this case, by using Newton's laws of motion, the differential equation of motion of the pendulum is given by this equation 1. And we reduce the number of parameters by choosing this factor omega d raised to power minus 1 as unit of time. And this equation can be further simplified, which is given by this equation 2, d2 theta by dt square plus d into d theta by dt plus omega square sine theta equal to a sine t. So this is a second order nonlinear differential equation because of the term sine theta. And we have used this notation omega square as g by l, etc. So we have solved this differential equation of motion of the pendulum for different values of the parameter a. And for the first value, that is a equal to 0, in that case, there is no driven force. And it can be proved that we have solved the system of equations, and there are so many things like eigenvalues and nature of the fixed points of the solution. So it can be shown that the origin 0, 0 is the asymptotically stable critical point for this pendulum system. And after finding the solution of the pendulum system, we obtain the graph of the solution, that is the curve for different initial values of the time period. So it can be observed that, so these are different solutions, and one can observe that initially the system is harmonic. The oscillations are there in the pendulum system, but gradually as time passes, the oscillations become tend to 0. So as it is expected for the absence of the driven force. So as we change on the values of the parameter a, and we take another value here it is.
Sorry, sir, for interfere to you. Your sharing screen has been stopped.
Okay, let me check.
If possible, you can share.
Yeah, sure. Okay. There is some.
It's okay. If it is possible, then share. Otherwise, you can. Okay.
Yeah, I'm sharing.
Yes, it's visible, sir. Thank you. Continue, sir.
Okay. So is it visible now? Yes.
Yes, sir.
Okay. So we have taken different values of this parameter a, and then later for the first value, that is a equal to 0, as we can expect that there should be no other kinds of motion in the pendulum except the harmonic motion, and we obtained the solution of the pendulum system. For the value a is equal to 0.4, again we have obtained the solution, and the nature of the solution or curve is as shown in this figure 3. This is for the value of the parameter a equal to 0.4. So we can observe that after initial transient, that is initial displacement, the solution is harmonic with the period of oscillations 6.33, which is approximately equal to the period 2 pi of the driven force. So remember that here the driven force has natural frequency of 2 pi because of the sine term is there. So another way of observing the period of the solutions is by means of the phase portrait. And in this case, we obtained the phase portrait also. All these figures are obtained by using the MATLAB software. And here, this is the phase portrait, and we can observe that there is a, after the transient decay, there is a closed orbit of period 1. So this indicates that the solution is harmonic with period 2 pi. This is the Pine-Cure section, and we can observe there is single dot, which indicates that the periodic solution is there with period equal to 2 pi. As we go on changing the values of the parameter a, for the parameter value a is equal to 2.4, the solutions are observed to be periodic with period 2 times 2 pi. So initially it was 2 pi, and for the value a is equal to 2.4, the periodic solution is there with period 2 times 2 pi, So the period has become doubled. So this is a period doubling phenomenon which is observed, and solution curves in this case also are obtained, and we can observe different. The solution is harmonic after initial decay is there. So going on changing this kind of values of the parameters,
I think he's disconnected. Okay, okay. Thank you, sir. Okay, I just repeat again. There are the two presenters. If they are the present, Miss Harsha KK is there. Miss Harsha KK. Okay. Miss Deepika Solanki is there. Miss Deepika Solanki. Okay, sir. So I would like to say thanks, Chief Organizer Dr. Bedkar sir, Event Organizer Professor Dr. Karad sir, and convener of this e-conference on mathematics, Mrs. Jyoti Bhosle ma'am, to give me a great opportunity as a chairperson of this session. So I hand over the charge of this virtual platform to the event organizer, Professor Dr. Karad sir. Karad sir, please.
Thank you, Dr. Handibag sir, for being a chairperson of this technical session. I also thank for running this technical session, assessing the research papers of paper presenters, and for your valuable concluding remarks. Now, after this, I would like to invite convener of this international e-conference, Professor Jyoti Bhosle sir, HOD Department of Kumarswami College, Ausa. Please, ma'am, I welcome you for vote of thanks.
Thank you, sir.
Welcome.
Good evening, everyone. Myself, Bhosle Jyoti, convener of this e-conference and HOD Mathematics Department, Shri Kumarswami Mahavidyalaya Ausa. It's my great pleasure to give me opportunity as a convener. First of all, special thanks to respected Dr. Bedkar MM Sir, Principal SKS College Ausa, and Chief Organizer of this conference. Dr. Bedkar Sir always encouraging us. My special thanks to keynote speaker Herdiana Dewi Nurfika, ma'am, founder and CEO of Bliss Education Center, Indonesia. She spent with us valuable time and give fruitful information about the attitudes towards mathematics and learning styles. Thank you, ma'am. Special thanks to respected Dr. Handibag sir, today's chairperson of technical session, research supervisor and head department of mathematics, Mahatma Bashweshwar Mahavidyalaya Latur. He gave their valuable time for this conference and accepted our invitation as a chairperson of technical session. Thank you, sir. My special thanks to Dr. Karad PD sir, event coordinator. Also special thanks to paper presenter, Ms. Tanya Dogra ma'am, Dr. Pramod Kulkarni sir, Bhupesh Nemniwar sir. Also, thank you, Dr. Swanand Shukla sir, interacting with us. Behalf of organizing committee and our college, thank you everyone present here. Thank you. Thank you.
Thank you, sir. Thank you so much,
Thank you.
sir. Good night,
Thank
all
you,
of
sir.
you. Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Thank you very much.
Excuse me. Excuse me. Sir, feedback link is not working. Yes, sir.